on this, I asked you to kind of start on this, and then we're going to talk through it here in a second. All right. I asked you if I give you 240, obviously with what we did yesterday, we can't put 240 on our fingers, so we need a reference angle. What's the reference angle for 240? 60. And how do you get 60? Subtract 180 from it. So 240 minus 180 is 60. That's my reference angle. Okay? 5 pi over 3. What is my reference angle? Pi over 3. The nice thing about this, I almost like them in radians because all I do is just take the pi and divide it by whatever's on the bottom. So pi over 3 is my reference angle. What is pi over 3?
60 degrees.
It's 60 degrees. It's 180 divided by 3. Because pi and 180 are the same. So pi over 3 is 60. So now I'll have the correct finger to use. All right? And then 150. What is the reference angle for 150? 30. Because we do that by doing 180 minus 150, and I get 30. Okay? So that's what I asked you to do. I asked you to find the reference angle. Now, we're not done there. Now let's go back and let's apply what's going on. Before we do that, let's go talk about this little piece here. All right? So determine which trig ratios are positive in each quadrant. Well, let's talk about them. All right? So let's talk about sine. What does sine represent? It's y, and cosine is? X, and tangent is slope, or y over x. Yeah. So in this quadrant right here, sine is what? Is positive. The y is positive. Cosine is positive, and tangent is also positive. All right. So really, when we're dealing in the first quadrant, I don't have to worry about anything. They're all positive. Okay. If I go to the second quadrant, what is sine? Sine is positive because it's the y value. The y value is positive right there. What is cosine?
Negative.
Negative. All right. And what is tangent? Negative. How do you find tangent? Rise over run, which would be the y over the x. So I've got positive and negative, so that's going to be negative. Or if I were to draw a line in the second quadrant, what's the slope of that line? It's negative. So that's the two ways that I can kind of think about that. All right. Go to the third quadrant. Sine is negative. Cosine is negative. And tangent is, that's kind of the weird one. All right. I got a negative over negative. So it's now a positive for tangent. All right. And again, if I drew a line right there, that would be a positive slope because that's what tangent is. Okay. And in the final one, in quadrant 4, sine is negative. Cosine is positive, and tangent is negative. Okay? All right. So there's kind of the full picture. I did more than what they really asked for because what they asked for there is what? Which ones are positive. So you kind of just got to remember which one's positive, and everything else is kind of negative. Well, in the first quadrant, what's positive? All of them are. Okay? All of them are positive there in the first quadrant. Okay? In the second quadrant, which one's positive? Sine. In the third quadrant, the one that's positive, tangent, sorry. And in the fourth quadrant, and then it's cosine. Okay? Now, I think we're kind of starting to understand this pretty well. If we're thinking about x's and y's and slopes and things like that, all right? I think you can kind of visualize this pretty easy. If I'm talking about sine, where is sine positive? Up here, right? It's y, so it's positive here. Sine is negative down here, all right? Cosine, positive over here. I feel like I'm dancing, all right? And it's negative over here, all right? And then tangent, it's positive there because that's my slope, all right? And it's negative there. That's the full extent of Coach Rice's dancing right there, all right? So, I gave you a little acronym last year. If you like it, told you I like reading my Bible every morning, and Acts is one of my favorite books to read. All right. So if you need an acronym, ACTS, if that helps you, use it. But I think right now a lot of us are visualizing. We know where things are going. Okay. Now we've got to have that to be able to finish these problems down here. Okay? So if I were to go to this, if I were to go to the sine of 240, we said the reference angle was 60, so we take and we put 60 on our fingers. All right? What is the sine of 60? Square root of 3 over 2. Yeah, we talked about it yesterday. Remember, the fingers go inside the radical. So square root of 3 fingers, and it's always over 2. Now, the only other thing that could happen here is this might be negative. All right? So where is the sine of 240 located? Or where is 240 located? Quadrant 3. What do I know about sine right there? It is negative, so I have to include a negative, and that's my answer. So that's the extra step that we're adding today. Okay?
If it says ratio, is that?
The ratio is the square root of 3 over 2, or the 1/2, the square root of 2 over 2.
Okay.
All right? So that's that ratio. So when we're talking about, like we can find the x and y values in that unit circle, it's a ratio. So if I went from a unit circle to like a bigger circle, or whatever, like a 3, I increase it by a time of 3, then I would take my ratio and I'd increase by 3, and I could get that next x or whatever. Okay? All right. Pi over 3. What did we say pi over 3 was? It was also 60, but now it's cosine, so we're talking about the top finger. And so square root of 1 over 2, which would be 1/2. Now again, the only thing I got to double check, is it positive or is it negative? Where is 5 pi over 3 located? Third quadrant or fourth quadrant? Fourth quadrant. What is all the way around? 360 or 2 pi or 6/3, yes. All right. So 6 over 3 is 2. So if 6 over 3 is all the way around, then 5 over 3 is just a little bit short of that. Okay? Puts me in the fourth quadrant. What do I know about cosine in the fourth quadrant? It's positive. So that one's good. Just gonna leave that alone. All right? And then I gotta go do tangent. Tangent of 30. Put my 30 finger down. How do we do tangent on the fingers? We gotta do both fingers. So square root of 1 and square root of 3. So sines on the bottom, cosines on the top as far as my fingers are concerned. Flip my hand over if I need to. All right. This is the tricky one because this is what? There. So I have to fix it. So square root of 3 over 3. So that's my answer. Gotta double check to make sure if it's positive or negative. Where is 150 located?
Second.
Second. What do I know about the tangent there? It's negative. And if I know tangent slope, if I look at that line, it's got a negative slope. So I have that there. Okay? Everybody good there? All right. Here's what I'd like for you to do. On the next little bit, I want you to draw this angle. All right? Draw these two angles and then find the reference angles. Okay? So on those next two, draw the angle and find the reference angles.
Happy to look over and see.
All right. 330. Which quadrant is 330 in? The fourth. We're just about all the way around. All right. So there's 330 right there. Obviously, I don't have enough fingers for 330. So what is my reference angle? 30. So I need that. That is my reference angle. So 360 minus 330 is the 30. I'm going to put 30 on my fingers. All right. So when I put 30 there, what's the sine of 30? Square root of 1 over 2, or just 1/2. Okay? And then I got to be mindful, what is the sign in this quadrant right here?
Negative.
It is negative. So add a negative to it, and I've got it. Okay?
What does that mean? What is negative 1/2?
That's actually the y value. So if I went 330, okay? If I went 330 on my unit circle and I stopped right there, then that y value of this point is negative a half. Okay? So remember the other day we found the point and we used cosine and sine to find the point there. So that's another thing we're doing. All right. So all of these things, if I have that angle measure, that ratio of that side is that, and that point is also that. Okay? All right. 5 pi over 4. Where's 5 pi over 4? Quadrant 3. Okay? Quadrant 3. So 5 pi over 4 is right there. How do we know, how can you tell somebody that it's 5 pi over 4 is in quadrant 3?
Because it's half 4 plus
Okay? So 4 over 4 is what?
1.
It's 1, it's pi. Okay? So 4 over 4 gets me to here. I got to go a little bit farther. 5 over 4 would put me into the third quadrant. All right? Now again, the shortcut is, I don't care what's on top. Take my pi, take what's on bottom. That's my reference angle. All right? So pi over 4 is your reference angle, which is a 45. So put my 45 finger down. This is the one that hopefully you don't ever screw up because it's the same on top and on bottom. So square root of 2 fingers over 2. All right? The top fingers. All right? And then is it positive or is it negative? It is negative because cosine is x and it's negative on this part of the graph. Okay? All right. Good there? All right. Next, this one's just a little bit different. It's asking me to find the sine, cosine, and tangent. So find all three of those ratios when x or when my angle is 3 pi over 4. So I'll give you a little time, see if you can find those. Find sine, cosine, and tangent when my angle is 3 pi over 4. What's your reference angle? Pi over 4, 45. Okay, pi over 4, 45. So put my 45 finger down. So sine is square root of 2 over 2. Cosine is? Okay, yeah, it may be negative. We'll look at it here in a second. I'm just writing down those. I'll check the negatives in a second. And then the tangent is 1. By the way, does that make sense for the tangent to be 1? If I'm going on a 45-degree angle,
Yeah.
I'm climbing as much as I'm running, right? So that slope is 1. So it kind of makes sense there. All right. Now, we do have to make sure that we do positive and negative. So everything's going to probably have negatives in it unless I'm in which quadrant? The first quadrant. Now, which quadrant am I in? I'm in the second. Kind of for the same reason we just talked about on that previous one. 4 over 4 was right here. 3 over 4 is 1 less. So I'm in the second quadrant. What's sign in that one?
Positive.
Positive. Cosine?
Negative.
Negative. And tangent? Negative. So there it is. Okay? All right. I'm going to give you a little bit of time. There's 6 problems on the next little bit here. I'm going to give you a little time, let you kind of work on those, and then we'll go over those here in a second. All right? All right. So spend some time on those next 6. Try those. If you need to do a quick little sketch, that's fine.
For each trig ratio, does it mean do all 3?
No. For the one that's listed. Yeah. Only do it for the sine or cosine or whatever's listed.
Oh, yeah. We're just trying to throw a hint so please.
Radiance index or
Yeah,
whatever is
it's
way
way
higher
further
than in
than
the middle.
here.
Is that because we're just further?
Determine a trig ratio and the negative ratio.
Because we're on a little bit older.
her,
Big dog.
And we applied sunscreen, but like if you don't continue to apply, and that was there in June too. It doesn't change as much there. But, my wife got like a second three something.
There was more tears.
Happy honeymoon.
Yeah.
Where's my dad? He said he got, well, you guys still say he got like fever and stuff.
Sometimes I think.
Yeah.
How often is like often? Like once an hour?
It says on there, like it, like
It's
for
like
us.
3 hours.
It says every 3 to 4, but that's for like not for Jamaica.
Probably put a little more on it than me.
Maybe you can just like cover it, like, I mean, unless you're like at the regular page.
We need good pots.
This is an interesting concept.
So distracted me from
You've never been
well,
to-
you're naturally have a little more adaptation with sunlight.
I have, that's great.
That's not great, it's true, it's called that melanin.
I did see this in
Melanin?
Melatonin, you have high melatonin.
I saw a Mason lady the other day.
You think we take melatonin?
Yeah.
And a cheeseburger? I never heard of cheeseburger.
I walked in.
I'm about to say.
Amazing.
Get out of here.
Can you test your whole body like brown?
Yeah.
I saw that the hand
Everybody
vlog.
black.
Like, yes.
You saw that
So,
thing?
I become black.
You saw Iron
So I become black.
MGK looks so tough.
It's a tailgate for a group. Every,
No, because it looks.
I saw money doing that, but it's outside there.
When it says negative 135, I mean you go the other way.
Go the other way.
You come back and you're like, I'm black.
Bro, I saw.
Speaking of, say black.
Cause like, let's hear you, but she's gonna be black. So,
Would you just get black?
I think.
No, I actually wanted to try that myself too, but then I'm like.
I said you try it.
I should, right?
I'm gonna do like half of your face so that way you don't mess it up.
Yes, I think.
I don't know, why would you tan like the rest of your body?
Oh, because.
Oh, okay.
Throw you where your chocolate from.
It's in here somewhere. I've got 5 million favorite
This is it.
I don't even, and then the thing is like, I keep them, so I don't even know like, which notes packet is it. I think this is from last unit. These?
That's from 2 years ago.
Oh, great. Didn't I give them like yesterday?
Alright, here you go, let's talk. So, 225, obviously that doesn't fit on my fingers. What's that reference angle? What's kind of the clue? It ends in a 5, right? Not everything ends in 5, but if we're doing this, if they're asking you to do this by hand, alright? If it ends in a 5, then it's probably a 45. So 45, 135, 225, 315, alright? So this is a 45, so put my 45 finger down, and I get square root of 2 over 2, alright? Now I just gotta make sure, is it positive or is it negative? Where is the sign, or where's 225? Right there, and it is negative. Okay, so that's that. We'll go across. 120, what is the reference angle for 120? 60, how do we get that? 180 minus 120. So it's 60 is my reference angle, alright? Put my 60 finger down. Sine is what?
3.
Sign is.
Square root of 3.
Yes, square root of 3 over 2.
Square root of 3 over 2.
Yes, King.
Alright?
It's positive.
And it's positive because we're in which quadrant?
Second.
Second quadrant. Sine is positive there, so that just stays the same. That's my answers. Okay? What's my reference angle on C?
Pi over 3.
Pi over 3, which is a 60. Alright? So that is
1/2.
square root of 1 over 2 or 1/2. Yeah, I'm writing the square root of 1 for you, but a lot of times I'm just going straight to the 1/2. I got it, okay? Is it positive, is it negative?
It would be positive.
It is positive. Which quadrant is that in?
It's on the fourth.
It's in the fourth. Cosine is positive on the right side of the graph. It's x. Okay? So that one stayed the same. Alright? On this one, this is kind of the tricky one. Question D. Alright? What's taking place there? What's different about it? It's going backwards. So negative 135. Positive 135 puts me there. Negative 135 puts me there. Okay? It's a 35, 135, so that's a 45. Put my 45 finger down. When I do tangent, I gotta use what?
Sine over cosine.
Sine over cosine, I gotta use both sets of fingers. Which that is?
1.
1.
Excuse me.
Positive 1 or negative 1?
Positive.
Positive 1. Take the slope.
Yes.
Alright? You look at the slope, it's positive, or you can think x and y are both negative, so negative over negative is positive. Okay? What angle is this one? This is 270. What kind of angle did we call that? Quadrantal. Alright? Which means my answers are zeros, ones, or negative ones. Alright? 270 is straight down. Alright? And so what's the x value that takes me straight down? 0. Alright? Anybody do it differently? What's your reference angle if you wanted to do reference angles?
5.
Pi over 2, which is a 90. Put your 90 finger down. What's cosine?
0.
There's nothing up there, so it's 0, so you do it that way as well.
Oh, I did double check.
Okay? Alright? Reference angle on this one.
5 over 6.
Pi over 6, which is a 30. So put my 30 finger down. This is the one I don't like. Square root of 1 over square root of 3.
No.
I gotta fix it because it's 1 over square root of 3, which would be square root of 3 over 3. Okay?
Tangent.
Again?
Throwing gang signs.
Oh, yeah. Alright. Where's 11 pi over 6?
It'd be 4.
Quadrant 4.
Right.
Because 12 over 6 is 2 pi. It's almost all the way around. So it's just shy of that. And it is negative there. So it's that. Alright? Everybody okay with those? Okay. Alright. Take a look. We got a couple more questions. We're almost done. Hang with me. Alright. Kind of building on this, so we're not just doing like a single one anymore. Now we kind of got a couple of these lumped together. Alright? I think we have to flip the packet over. Is that right?
Yes.
Right. So what do you notice in part A? That looks weird. It's a square. So why did they do that? Now technically, if you're going to type this into the calculator, you can't type that in the calculator like that. There's not a way to put that into the calculator this way. Okay? The way that we have to put this in is tangent of 5 pi over 4, all right? And then we're squaring the whole thing. That's what that means. Yes, sir.
Wait, that one doesn't matter because it's undefined either way, right?
What do you mean?
Or I was thinking that was 5 pi over 2.
I got you. Yeah. Okay. Yeah. If that was the case, then you're right. Okay. And so this, now we write it this way right here because if you're not careful, if you were to write this, so I left off a set of parentheses and I write it like that, that means something different.
It doubles it.
Now we're squaring just the angle and not the actual trig function, all right, not the ratio. Make sense? And so in an effort to kind of not be confusing here, that's why we put the 2 there. And so it kind of differentiates which operation we're wanting to do, all right? But again, if we want to put it in the calculator, we got to put it in the calculator like this. So we're going to take the tangent of 5 pi over 4, and whenever we get that answer, then we're going to square it. Which is good and bad news a lot of times. So on this one, what is pi over 4? Or the reference angle is pi over 4. All right? So pi over 4 would be a 45. It would be square root of 2 over square root of 2, which is 1. Are you really concerned if it's 1 or -1?
No.
Not in this case, why? Because I'm squaring it, right? So it's gonna be positive. Now, that's not good practice, just to do that, but because of the square, I can do that. Would it be a positive or would it be a negative? It would be a positive. It's in this quadrant, that slope is positive, so 1 squared would be 1. Now, some of you going, I don't like that square, that bothers me. Actually, I kinda like it sometimes. Why? What are a lot of our ratios look like?
Like square roots,
So if I had this and I squared it, what would be nice about that?
you get rid of the square root.
Get rid of the square root. So if I squared the square root of 3/2, I'd get 3/4. So I like it because it kind of simplifies it a little bit more.
Yeah.
As well. Okay? Alright, so that's if we were to square it. Take a look at part B. What's it asking me to do on part B?
Multiply the
Just
two.
kind of multiply them all out. So we can see that in an operation. We have 8 times sine of pi over 3 times cosine of 5 pi over 6. So it's asking me to just multiply all that out. So if I were to do that, I've got 8 times pi over 3. What is sine of pi over 3?
30, wait, so 60.
It's a 60, okay? So it's 60.
Square root of 3/2.
Square root of 3/2. And am I worried about positive or negative on that?
No.
Where's pi over 3? It's first quadrant, right? Now, I'm gonna go and make 8/1 just because I see the fraction happening there, so I'm gonna make that a little bit easier, alright? And then I gotta do 5 pi over 6. Cosine of 5 pi over 6. What is pi over 6? It's a 30, okay? So my reference angle is pi over 6 is 30. So put my 30 down. Cosine is the top. So that is square root of 3/2. Now, I'm not in the first quadrant on that one. I'm where?
In the four.
Second.
I'm in the second,
Wait. Oh, yeah.
okay?
Yeah, my-
Because 6/6 would be right here. 6/6 would be 1. So I'm backwards 1, so I'm in 5 pi over 6 would be in quadrant 2. Alright? So what do I know about cosine in quadrant 2?
It'd be negative.
It's negative. Alright. Good news and bad news about what you see there. Anything? Somebody going, oh, there's no good news about that. Alright.
Cancel the square root.
Cancel the square roots. How can we do that?
Square root of 3 times square root.
Okay, square root of 3 times square root of 3 is 3, because you could say I'm multiplying it by itself, right? I'm squaring it, so square gets rid of square root. Or you could say square root of 3 times square root of 3 is square root of 9, which is 3, alright? So when I put these together right there, that gives me -3. 2 times 2 on bottom is 4. And
I mean, that's not that bad.
these are simplified. What's 8 divided by 4?
That is
2. 2 times -3 is
negative 6.
-6. So all that work up there simplified down just to -6. Okay? They won't always simplify that nicely, but sometimes they do. Okay.
Subtraction.
Yes. So part C is a subtraction problem. So here's what I want you to do first. I'm gonna give you a little time. I want you to go find me the sine of 3 pi over 4 and find me the cosine of 5 pi over 4. So I'll give you a little time there. Go find the sine of 3 pi over 4 and the cosine of 5 pi over 4. What's reference angle?
Referencing for sine?
45
They're both 45s, right? Except what? There are 2 different quadrants, right? So I'm going to go and do this. That's square root of 2 over 2. That's square root of 2 over 2. I'm going to make sure that I have my negative in there. All right? Where's 3 pi over 4?
Second.
second quadrant, which is positive for sine, so that one's there. Where's 5 pi over 4? It's third, so the cosine is negative, so that's negative. Now, if I didn't pick up on that double negative, what did you just do with them?
Add 'em. Wait.
Yeah, if I hadn't had that second negative, you just subtract them and it's 0, right? Because they're the same. But in this case, it's negative a negative, so it's plus a positive, so I need to add those together. You okay with the way that it's set up? Yeah, because with adding or subtracting fractions, it's gonna have common denominators, which we have, so that's good, all right? If I were to give you this problem, this is a separate problem. If I were to give you this, can you add those? Yeah, so what would that be? 2x over 2. Don't add the denominator, it's still the same. So it'd be 2x over 4. Same idea here, all right? A lot of people don't like adding these radicals because they don't like the way that they look, but I'm going to treat these like x's. So the square root of 2 plus the square root of 2 is 2 square roots of 2. I got 2 of those. 2 square roots of 2 over 2. Now, what can we do with either one of these?
Eliminate the 2.
Eliminate the 2's, all right? So the 2's would go there, so it would be x. In this case, I would have eliminated the 2's, and I would have said square root of 2. So that is my final answer for that. Okay, everybody there? All right, down to the last problem. Take a look, read that last problem, and then we will discuss. What's different about this one?
Is asking for the angles.
Mm-hmm. It's asking for the angles. It's not asking, they normally give me the angles, all right? But now it's asking for the angles, all right? And it's asking for the angles here. What does that mean?
Circle.
One full circle. 0 to 2 pi is one time around the circle, all right? How many times are there, how many answers are there for one time around the circle? Most of the time?
2.
There's normally 2, right? Because if you think about sine, both signs are positive here, so I have 2 signs, or I have 2 negative signs. 2 positive cosines, 2 negative cosines, all right? Now there's a couple that you might only have 1, or you might have more than 2, but for the most part, I'm looking for 2 answers, okay? Where is the cosine 1/2? 60. How can you prove that? Use your fingers, all right? If I'm wanting cosine, I need cosine to be 1. I need to have 1 finger there. I put the 60 finger down. That's my answer. So this is a 60 is what I want, okay? So if I look at this, theta is equal to 60. I found that, all right? Now, where's the other one?
300.
300.
Across the x-axis.
Because cosine's positive here and positive there. Cosine's 1/2 in both of those locations. All right? So 60 and 360 minus 60 would be 300. Okay? Now, why did I say looking for 2 here? Why did I look at the domain on that? Because technically, if I kept spinning circles, do I still get answers?
Yeah.
All right? So I can keep going, like, if I went all the way around and came back to 60 again, so 60 plus 360 would be 420, and that would be another answer. And add 360 to that one, so 660 would be another answer. And I keep going, I keep going, I keep going. I don't want to do that, all right? We're just going one time around the circle, all right? Now, technically this is not correct. We talked about it yesterday. Why is it not correct?
It's in degrees and not radians.
It's in degrees instead of, it told me in radians, all right, so I need to put it in radians. So what is 60 in radians? Pi over 3, all right, which means this should be some form of pi over 3. Say again? 5 pi over 3, yeah, 5 pi over 3, because this would be 6 pi over 3, because that's 2 pi, go backwards 1, 5 pi over 3. Okay? Everybody good? All right. I know you're very disappointed in me. I don't have anything homework for you tonight, so not sure if you'll be able to handle yourself. Alright,
Let's do go by free time tonight.
yes, ma'am?
So you know how we were going from degrees to radians, you like just multiply by 180?
Uh-huh.
Is there a way you can do that for this one? Like to get from rate?
Yeah, you could do this right here, you could go that, and you could multiply, by pi over 180.
Okay,
That's that same conversion, remember, think about stoichiometry, you gotta have the degrees on the bottom.
just do 60 divided by 180.
60 divided by 180 would be a 3 on the bottom. With pi on top. Yeah. Remember, we took the 180 over pi or pi over 180, whichever one I need for that certain one. Yeah.
This Mr. Rosa,